Hello everyone, welcome to my channel again. So today we will discuss one problem from Leetcode, that is unique path 2, and the problem number is 63. So before coming to this problem, I will highly recommend you to go through this problem, that is unique paths. After completing this problem, if you come to this problem, it will be very easy to understand. The problem statement is saying a robot is located at the top left corner of a m into n grid, which is the start point. The robot can only move either downside or the right side at any point of time. The robot is trying to reach the bottom right corner of the grid marked as finished. Now consider if some obstacles are added to the grid, how many unique paths would there be? An obstacle and space is marked as 1 and 0 respectively. So here is one example. Here if you see, this is a m into n grid where this is the start point and this is the end point. Now this red color thing is a stone or obstacle you can think about. So obstacle means you can't pass through that road. So from here to here, if you have to come, there is two way. Either you have to go to right side or down side in any movement. Then you have to tell like how many way you can come from start to the end point. So you'll be provided with a obstacle grid matrix where 0 means empty space and 1 means a grid is one obstacle is present. So here if you see, this will be one path and this will be one path. So total two way you can come from the start point to the end point. Now here is one 3 into 4 matrix where we have denoted this part as some obstacles. And from start to end we have to move, and only movement allowed is either right side or down side. Now if we check here how many way we can move from start to end. So one path can be possible as start we can do like this, then we can move, then we can go like this and we can finish here. Another path possible is like this, then come here. Is there any other path possible? So if we go straight, we can't go further because obstacle is already there, so we can't reach to this place. And if we go straight, we can't move to the right side because one obstacle is here. So this space also we can't go. Another path possible can be this way we can come, then this way we can go, then downside, then right. Same another path can be possible like this, then this path, and we can go. So total four way we can come from the start and finish point. We have to determine this programmatically. So one clue we already got, right. So the thing is, if in the first row or in the first column one stone is present, so after the stone we can't access that area. So this area we can't access. So if a stone is here also present, that time also we can't access this area. So this is the observation which will help us later on. Now we have to check how we can solve this problem. So our end goal is to start from here and finish here. So if we have to check and divide it into some small problem, then what we can do is this end point we can move closer to the start point and do some observation. Suppose we can mark my end point as here, or maybe my end point can be here also, or here. So I am marking few areas as my end point and I will try to observe what will the result I am getting. So suppose these are my possible end points. Now I'll just change the color. Now if I have to reach from start to this point, then how many way we can come here? So here to here only one way is possible. Means if this is my end point. Now if this is my end point, how I can reach? From start point to this point I can't reach because there is one stone present here. So I can't go further. So zero way we can move from start point to this point. Now if my end point is here, how many way I can come here? One way we can come here. If my end point is here, there also in one way I can come only. Because right after going left I can't come, right? So there is only one way. Now here if we have to come, how many ways I can come? Either via this route or via this route. So total two way. If you remember the unique path 1 problem, so there what we have defined is this 2 is actually the addition of the top value minus plus the left side. So From top one way we can come here, and from left we can come one way. So 1 plus 1 total 2 way we can come here. And as stone is here, so we can denote the stones as 0. Means to reach this stone, 0 way we can go, right? So now if we have to come here, then how many way we can come? That will be 2 plus 0, 2 way. Now if you check also, that is true, because one way is this one and another way is this path. Now same will be here also, right? So by adding the top side and the left side subpaths, we can get the current position, like how many way we can reach to this position. So now I have to clear this and complete all this path. So now one observation we got is, for the first row or the first column, if my end point is present, then if stone is not present, then one way we can come. If stone is present, then obviously 0 way. And after stone, I can't access anything. So that will be a 0 way. Here also stone is not present, that's why all will be 1. If suppose stone is here, then it will be 0. Right. Now, here how many way we can come? That is 1 plus 1, that will be 2. Here how many way we can come? 2 plus 0, that will be 2. Here 2 plus 0, that will be 2. Now as stone is there, means we can consider it as a 0, right? So here how many way we can come? That is 0 plus 2, 2, and here 2 plus 2, 4. So total 4 way we can come from start point to this end point. Now we have to check, if we have to check for the paths, then we can change the color and check. So one path possible will be this one. So this is the one way we can come. Then another path possible is this one. Then another path possible is this one, and this will be another path. So total 4 way we can come from the start to the end. So now before starting with the program, whatever point we gathered, we'll just note down. One is, for row 1 and column 1, only one path is possible, and after obstacle path will be 0. This is right? Because for row 1 and column 1, if my end point is present, so that time all the path will be 1. Or if obstacle is present, after obstacle, that will be considered as 0. Now to keep hold of these values and get to the ultimate answer, we have to form a DP array or memoization technique, right? As it is a dynamic way of programming, where we are taking help of pre-calculated values to get into the result. So that will be a two-dimension array of same column and row size, right? Then apart from the first row or the first column, for any other column, what we have to follow is, that time dp of I j, means for this cell you can consider, that will be dp of I minus 1 j plus dp of I j minus 1, means top and left one we have to add to get the current cell's dp. Time complexity wise, what will be the time complexity? As we are traversing row, and for each row we are traversing all the columns, so we are using actually two for loops, right? So that will be time complexity wise O of m into n. And space complexity, as we are maintaining a DP array, that will take O m n of space. But in O1 of space also we can do this problem. How? Because initially you will be given with one obstacle grid array as an input. You can keep on updating that array while doing the program. No need to take another two-dimensional array to do this program. In the same array itself, you can update the values and get the result. Maybe the problem or the program writing time, it will be a bit different. Okay, you have to use some condition, but you can make use of this obstacle grid and solve this problem. That time there is no extra space required, and you can space complexity wise in O1 space you can finish this problem. Now let's see the coding. Now coming to the programming part, so here I am using a DP array. You can use or update in the same obstacle grid also. So here I just use a DP array of length m and n to solve this problem, where m and n is the row length and the column length. So first what I am doing is for the row 1, for row 1 I am checking if obstacle is not there, then I am updating the DP array to 1, and if I get any stone then I am breaking the loop, because by default other part of the row will be 0. Same for the column also. So in the same column I am checking for 0. If the 0 is there, till then I will update it as 1. If I get a stone, then I will break. Now then I will start my like ij from 1 and 1 position, because the operation for the first row and the first column is done. And after that I'm checking if obstacle grid is there, means it is I at j equal to 1, then that time I have to place a 0 here. If I just do a continue, that means I'm doing nothing. By default that array will contain the 0 value. And if it is stone is not there, that time I am doing is dp of ij will be dp of I minus 1 j and dp of I j minus 1. And after all the calculations, the corner value I have to return, that is dp of m minus 1 n minus 1. Now let's submit this problem. Yeah, so it is working. Thanks for watching.